Welcome to a Land Rover guide to the Land Cruiser. Now this is a 1HZ engine, which is a 6-cylinder, 4.2 litre naturally aspirated direct injection engine. Compared to the 300 TDI, which is a 2.5 litre 4-cylinder turbocharged direct injection intercooled engine. Now these two engines pretty much make the same amount of power. The vehicles have got about the same gross vehicle weight. Defender's about 3,500 depending on the model. This is about 3,200. So the power output requirement is about the same, and the engines do actually produce about the same amount of torque and power. So what we've got is Toyota and Land Rover approached the problem of trying to get to a certain power level in a different way. Land Rover have taken a relatively small, older engine and bolted a turbo onto it. And what Toyota have done is gone for a bigger capacity without adding the turbo. Now, regardless of the fact this thing is massive and it makes it a larger engine bay, I think that's a better strategy from Toyota, because what you've ended up with is a bigger engine, a bigger block, therefore it's more reliable. Each cylinder is less stressed and the crankshaft is less stressed at each point, and you don't have a turbo in there, which means you don't have all the extra complexity of having to cool the oil a lot more because it produces so much more heat. You don't have the effect on the cooling system because it doesn't produce so much more heat. You don't have the additional pipework to get the oil to the turbo. You just don't have, there's a lot of things you don't require from a technological point of view to put on if you don't have a turbo. You've also got the reliability aspect, because turbos will probably fail before the engine does. Turbo might go 150 to 200,000 miles and the engine could go to 300,000, so that's more likely to fail. By not putting a turbo on this engine, they've made a massive improvement to the reliability of the vehicle. Because the only limiting factor is the engine, and they can cool it a lot more easily, and you don't need such a high quality of oil to run the turbo, for example. So the fact they've ended up with the same power output means that this is probably, from an expedition and utilitarian point of view, this is a better solution, I would think, by having a larger, less stressed engine. You can see that down here they've actually got the space for the turbocharger here, because there is a turbocharged version of this engine. So instead of making a different manifold, and they put this plate on here where the turbocharger would go, which is a brilliant design, because they only have one part for this regardless of the two different engines, and all you have to do is bolt in a turbocharger. It also makes it very easy to upgrade this engine with a turbocharger, because it's already got the space for it. You don't have to buy any extras. You just take that off and put the turbocharger in and have the associated pipework goes in there. This engine as well, being 6-cylinder, means it's a lot smoother. I'm just going to start the engine now, and this thing makes hardly any vibration. And as I say, it's 16 years old, 200,000 miles, and it just purrs. It's just amazing. I'm going to put the camera down next to the engine just so you can see how much vibration it makes on startup and running. I know that cameras aren't the best thing to pick up vibrations in general, but I think I can hardly feel that through the bodywork. That's amazing. That just makes it seem like such a more refined engine compared to the 300 TDI, which is pretty much a tractor engine by comparison. Give it a rev. Hardly any movement at all in the engine. There, I can put a bottle of water on the engine, and that's how much it's moving. That is impressive. Click here to go to the next video. Right here. That's where the button is. Right there.